All right, it's the top of the hour. I'd certainly like to welcome everyone to today's webinar, Isophase Bus System Maintenance in Action. My name is Scott Schwieger of Combined Cycle Journal, and this is a topic that comes up at user group meetings all over the world. And recently, I was able to see Brian O'Neill from RMS Energy give a presentation at the 7EA users group in St. Louis. And I thought it was really important to, get this content out to a virtual audience, and because it's very important. And I know it's on the tops of the users' minds at the moment. So right now, I would like to introduce Brian O'Neill he's the operations director at RMS Energy, and he's going to take it away for the next 40 minutes or so. Any questions that you might have, please put them in the chat or use the raise hand feature. Send them throughout the presentation, and we'll try to get everything answered at the end. So without further ado, Brian, take it away.
Good afternoon. My name is Brian O'Neill. I'm the Vice President of Operations for RMS Energy. I also manage our bus services division that focuses primarily on isolated phase bus, non-segregated phase bus, and cable bus projects. So today we'll talk about bus maintenance in action. I want to focus on a few topics. One is, why is bus duct maintenance important? So it is a critical asset in a facility, but a lot of times it doesn't get the focus for maintenance that other assets like transformers, generators get with regular maintenance cycles. But it is a critical asset. It does have the potential to put your plant into an outage. And generally, if there is a major issue with your bus duct, it can be costly and time consuming to repair and lead to a lot of lost production. We'll also talk about what bus duct maintenance means and some of the general concepts when you look at performing maintenance on your bus duct. There are some pretty simple concepts that'll get repeated in here, and it should look very similar to maintenance on other types of electrical equipment you're familiar with. So keeping it dry, reducing any moisture issues, keeping it clean from any type of contaminants and particles entering the bus duct, and then keeping your bolted connections properly maintained so you don't have overheating in your connections or in your grounding. And then a little bit we'll touch on what to consider when planning for maintenance for a bus duct and what that looks like in your outage. So a little background on RMS Energy. We're a nationwide electrical engineering, service and construction firm. We work primarily with large industrials and utility clients, performing inspections, repairs, maintenance, engineering, and turnkey projects. So we have a number of locations across the U.S. with our main headquarters being in Randall, Minnesota, which is about an hour north of Minneapolis. We've got locations in Cincinnati, Ohio, Panama City, Florida, Austin, Texas, and a number of other service locations close to our customers. And while today we'll talk mainly about bus duct solutions, we have a number of divisions perform work on transformers, doing new designs or new installations, maintenance and repairs, field services and commissioning, doing apparatus testing, relay testing, and maintenance. Our engineering group can do substation designs, transmission design, engineering studies, custom switchgear. We have a staff augmentation group in our professional services that supports with project management and safety personnel on site. And our advanced technologies group does online monitoring and Emsa testing as well. And again, with the focus on bus today, our bus solution groups does maintenance, inspections, and cleaning of bus duct. We do engineering in-house for upgrades and life extension of bus. We can also do new installations and custom modifications of existing equipment. We have the capability to work on all types of bus duct systems, regardless of vintage or manufacturer, and we're a preferred contractor by two U.S. bus manufacturers, Technobus and PAL. So there's a number of different types of bus systems that are found in plants. Today, we'll focus on a couple very common ones. We won't be able to touch on every style of bus. So one common type of bus found in plants is a cable bus system, where you've got medium voltage cables in a common metal enclosure. The same concepts for mechanical inspection apply as in non-seg or isophase bus, but there are some other electrical testing considerations that we won't touch on too much today. The non-segregated phase bus is a very common type of bus duct found in plants. It's separate metal conductors in a common metal enclosure. The non-segregated style, there's no barriers between phases, but there is a less common style that's a little bit older, usually called segregated phase bus, with a similar design, but there is a metal barrier between phases. So this bus can be found between your GSU and your generator as a main power branch, but it's also commonly found as medium voltage distribution within a plant. An isolated phase bus is for high ampacity applications. It's a solid metal conductor with each phase in a separate enclosure. There's a couple of design styles, older being the non-continuous design, but more commonly continuous design is used. And within that bus isophase design, there can be different configurations for conductor profile as well as insulator style and design. So when we talk about bus duct maintenance, really the focus is maintaining the critical components within the bus duct that allow it to perform as designed. So some of those critical components we'll discuss today are the flexible and bolted connections, insulators and mountings within the bus duct, seal off bushings and fire stops, also part of your insulation system, expansion bellows and rubber bellows. These are part of your enclosure system on the external of the bus duct, gaskets and hardware within the bus, proper grounding and isolation of your equipment. And then on some styles of bus duct, there are mechanical systems that support the operation, such as heaters, forced air cooling systems, and air pressurization systems. These aren't found on all types of bus duct, but if you do have them, they need to be maintained as well. So terminations and disconnect links, these provide a means to connect and isolate equipment from your bus duct. They're made up of a number of different components. You'll find braids and flexible connectors, adapter bars to transition from bushing to bus design, hardware, making your bolted connections and specifying the correct type of hardware and the proper torque, and then your plated contact surfaces, making sure they're in good condition and they're greased to prevent corrosion and other issues from occurring. So within that termination assembly, the flexible joints play a key role, but they can become damaged over time. So laminated style flexible links, they can crack due to vibration and airflow, reducing dielectric clearance in your terminations. You can also have rubbing and fraying from your flexible braids. Over time, this will reduce the cross section of the braid. It can also introduce conductive particles and strains into your bus duct as well. The bolted connections need to be properly maintained. They should be greased and the plated surfaces inspected and maintained. And also proper torque is important in a bolted connection as well. That can be preventing loose connections, but over torquing is also a concern. You can press material out from under those bolts, and overheating and cooling cycles will lead to a loose connection and a hot connection. Moisture also is a concern on your bolted connections. Over time can lead to corrosion, degradation of your plated surfaces, which will lead to high resistance connections and overheating after long periods of time. This becomes a compounding issue where more heat and a hotter connection can lead to more corrosion, eventually leading to some overheating and damage to the rest of your bus duct if it fails. We'll also talk about maintaining insulating materials in your insulation system within the bus duct. This is an image of a standoff type insulator commonly found in isolated phase bus. These can be made of epoxy or porcelain, but there are a number of other insulating materials found within non-seg bus and isolated phase bus. You can have fiberglass sheets and tubing for bracing and barriers, as well as epoxy or porcelain seal-off bushings that need to be maintained as well. So insulator supports need to be inspected periodically, make sure they're functioning as designed. Cracked and broken insulators reduce the dielectric capability of the insulators. It also eliminates the mechanical properties. So if you do have a short circuit, it can lead to additional damage within the bus and more broken insulators. This can also create misalignment in your conductor and reduce dielectric clearances if you have a major issue. Cracks can also accumulate moisture and debris, leading to phase to ground faults. So this is an image of an insulator. I had a crack running through it, filled with moisture over time, and led to a unit tripping off a line because of phase to ground faults. Insulators should also be periodically cleaned and inspected for tracking and partial discharge issues. Over time and in poor environments, insulators can lose their dielectric properties. So this is an example of a new insulator versus an old insulator in a bus that it wasn't maintained for long periods of time, was constantly exposed to moisture, and the corona and ozone buildup within the bus duct degraded the insulator material to a point where it wasn't functioning as it was designed. So insulators within a bus duct, they are C2910 type apparatus insulators for indoor equipment. So they're not designed to be exposed to moisture indefinitely. So it is important to make sure that moisture is kept out of the bus duct, heaters are working properly, because over time, if those insulators are exposed to moisture, they will begin to fail. And then if it's a first inspection for a bus duct, there can be issues from poor quality installation that are found that can be addressed. So some examples of that in these pictures is weld spatter, poor FME with leaving metal shavings inside the bus duct. But it's also common to find paint and tape and sometimes trash and debris left in a bus duct from installation. One reason why it's important to use a qualified contractor with good FME practices when you're looking at installing or making modifications to a bus duct. So another component, part of the insulation system within a bus duct is seal-off bushings, commonly found in isophase bus. So these can accumulate debris and moisture over long periods of time and begin to see partial discharge and tracking issues. One issue with these is sometimes they're located in inaccessible areas. So one side may be exposed at an equipment termination, but it may not have access covers on the back side where you can easily access to inspect or clean those seal-off bushings. Similar to seal-off bushing, fire stop barriers are found at your transformer blast walls, but many times these aren't designed with access covers to allow maintenance and inspection. So over time, you can accumulate moisture if it's at a low spot and have partial discharge and tracking issues. So one option, if you have a situation where you have inaccessible components, is access covers can be added after installation of the bus duct. There's a lot of options for that for aftermarket covers to allow you to get proper access to your bus duct for maintenance and inspection. So moving on to our enclosure system for the bus duct. This is the first line of defense in making sure that your bus remains in good condition. You extend the life of that equipment. It performs a big function in preventing the ingress of moisture and contaminants into the bus duct. There's a number of components to maintain and inspect periodically, including aluminum expansion bellows, rubber bellows at equipment terminations, gaskets at your access covers, and making sure that the hardware is in good shape, the right size hardware is used, and it's in good condition where it's not stripped or rusted. So the first step in extending the life of your bus duct is keeping your bus clean and keeping it dry and not allowing moisture and contaminants to accumulate on your internal insulation in that bus duct. So aluminum expansion bellows are used in isolated phase bus. They're designed to allow some movement in the bus during heating and cooling cycles, but over long periods of time, or if you have vibration issues, excessive movement can lead to failure of these. Once you're cracked and exposed to the elements, they can allow moisture and debris into the bus that becomes trapped and stagnant. Rubber bellows perform a similar function, but they're generally found at equipment disconnects. They can be torn over time or degraded due to UV and exposure to the elements, or improper installation after maintenance has been performed on connecting equipment. So these two can allow moisture and contaminants to enter the bus and become trapped. And then gaskets at your access covers. So gaskets do fail over time. They can become dry rotted, no longer perform as designed. Hardware can become stripped or rusted, all of which can allow moisture to enter the bus duct. So these need to be inspected, periodically replaced as part of your maintenance cycle. So moisture will be a repeating issue in this presentation. It's one of the most common causes of failure. Moisture has many ways to enter your bus duct through cracked insulation or cracked expansion bellows, torn rubber bellows, failing gaskets, and it's the most common cause of failure again. So the more you can do to reduce exposure of your insulation materials to moisture, the longer your bus will last. So this is an example of, on the left, moisture settling in a low point around the seal-off bushing. So this was corrected with adding some additional drain plugs. And on the right is an example of trapped moisture becoming condensation on the bus on the inside. So this is a telltale sign of moisture in your bus duct. Over time, that condensation can build up, settle into low points in the bus, and cause damage to other components. For example, heaters are typically located on the bottom of bus ducts and at low points. So that condensation can turn into standing water and cause failure on your heaters. It can also build up, and the humidity in there can support corrosion on your bolted connections and lead to additional failures in your bus duct. So it's important to note when you're doing periodic maintenance or an inspection, or even just testing and maintenance on adjacent equipment, if it's noticeable that there's standing water, condensation, or even just noticeable difference in humidity on the internal of the bus duct, you should take that as an opportunity to investigate where the source is and see if that can be mitigated. So debris and dust internal to the bus duct is also an issue, but when you combine the two, that dust, especially if it's conductive, can accumulate on your insulation and act as a sponge. It can hold moisture and create better conditions for surface tracking on your insulation internal to that bus duct. And then isolation and grounding. There's a number of different ways to ground bus duct, especially depending on the design, whether it's a continuous bus duct or a non-continuous. So really each system needs to be investigated to make sure that your grounding is done properly and equipment terminations are isolated properly, so you don't have eddy currents or circulating currents in your bus duct leading to overheating issues. So we mentioned some supporting systems that can be found in bus duct. Again, these aren't going to be located on every bus duct design, but they are important to maintain if your bus duct has these supporting systems. So a couple common ones are functioning heaters. So these are commonly found on outdoor bus duct. Heaters are located at insulators to protect them from accumulation of moisture and condensation. It also supports keeping the internal air slightly warmer than external to prevent moist air from entering the bus and becoming trapped. So it's important to check those periodically to make sure they're functioning as intended. Air pressurization systems supply clean, dry air to bus ducts. Provides a slight positive pressure to the inside of the bus duct to prevent moisture from entering the bus and becoming trapped. And one note, with these two systems, if you have an air pressurization system, you likely don't have heaters. So if you begin to see issues with maybe your seal-off bushings are failing or your gaskets are failing and you're not able to maintain pressure on that bus system any longer, you don't have a backup line of protection like you do with heaters. So it's important to maintain those systems and try to address issues with your pressurization if they occur. And then lastly, forced air cooling. That's typically found on high ampacity bus ducts. It provides additional cooling capacity to increase the current rating of the bus. It's typically it's pretty much an HVAC system attached to your bus duct to provide additional cooling on the bus, but it also removes moisture from the bus duct as well. So it's important to maintain that, ensure it's functioning properly, make sure your dampers are set properly for balanced airflow. So with these critical components in mind, we'll talk a little bit about planning for maintenance and what some considerations are before you enter an outage. So generally, again, maintenance is maintaining the critical components within your bus system and repairing any damage once you find it. So that can be replacing damaged bellows, whether they're rubber bellows or aluminum bellows, replacing gaskets and hardware periodically as they wear out. So gasket doesn't have an infinite shelf life and install life. So over time, those will fail and need to be replaced. Generally, as a practice, anytime we open an access cover, we try to replace the gasket as well with new gasket. Flexible braids will wear out over time or become corroded. Damage to insulators, or inspecting all your insulators to ensure there's no damage. Replacing non-functioning heaters, and then with your aluminum expansion bellows external to the bus, replacing them if they become cracked and are no longer keeping moisture and contaminants out of the bus duct. So a major consideration when planning for bus duct maintenance is inspection and access. So generally, to get to these components, you're going to have to remove many of the covers on the bus, if not all of them. But one consideration is how to inspect inaccessible areas. So we mentioned seal-off bushings and fire stop barriers. If there's no access to those areas, you may want to consider adding some inspection access covers so that you can inspect them in future outages. Again, access, very important. Most of the time, bus ducts are not in an easily accessible area. They can be 15, 20 foot or more off the ground. So you will need to work at heights to be able to maintain that bus duct. That can be done with scaffold or it can be done with man lifts. There's important considerations with both. Man lifts are generally cheaper than scaffold, but it also adds a lot of time to the maintenance process. So you'll need to weigh those options and see what's more important in your outage planning. What other contractors are going to be in the area? Is everyone going to be able to work on the equipment at the same time, or do you need to stage access? And then what other scopes are in the area? So transformer and generator testing can introduce high voltage into those terminations. So you want to ensure you don't have two contractors working on top of each other, where you can introduce high voltage into an area where someone's working. And also, part of your maintenance planning should be considering what work needs to be done and what the material requirements are. So generally, the hardware and gaskets are readily accessible, but some items can be long lead, such as rubber bellows. Most are easily found, but some specific designs can be they aren't off the shelf. They need to be custom made, so it can be 6 to 8 week lead times. So that's important to consider. One way you can plan for that is doing your best inspection while the outage or while the unit is energized. A lot of times you can see damaged gaskets and torn bellows from the ground. So trying to address those issues ahead of time. Cracked aluminum bellows, cracked welds should be repaired when they're found. That is a little bit more labor-intensive process. You will need 480 volt power. So is that coming from plant access, or do you need to plan for generators on site? Also vetting your contractors, making sure that they're qualified to work on that equipment, that they have a qualified welding program and skilled certified welders, and then planning for hot work permits and hot work in the area. And lastly, testing of your bus duct. So you will need to remove braids and isolate from all the other equipment, and then planning into your lockout, tag out, the removal of protective grounds or temporary test permits to allow you to AC and DC hot pot that bus as part of your closeout procedures. So if you are already performing inspection and maintenance, or you go into your first inspection and maintenance outage and find significant problems within your bus duct, there are some options for refurbishing that bus and extending the life of that equipment. So some examples: cryogenic cleaning can be used to remove accumulation of dust and debris in a bus. This is also common practice if you end up having an arcing fault somewhere in your bus system or your termination that fills that bus with contaminants and carbon debris. If your silver plated contacts begin to degrade or flake or peel, those can be replated on site. So as an example of a disconnect switch, it was beginning to see some big corrosion issues. The silver plating is basically gone on those terminations, and the flex braids were in rough condition. So as part of your outage planning, that silver plating can be done on site. It can be repainted and new hardware and new flex braids installed to bring it to like new condition. This is another example of a transformer bushing that was replaced. As part of that process, the bus duct ends were replated, new flexible braids and new hardware provided, so you have a like new condition termination to that bushing. So we've covered a lot of typical maintenance planning for bus duct and what maintenance actually looks like. But another step in planning your maintenance is gathering data and understanding how often you need to do it, and what issues you might have in focus areas you want to pay attention to during your limited outage windows. So online monitoring is becoming more popular. There are many options to provide data and planning for your outages. So we'll talk about a few here. So some of these online monitoring systems can be temperature and humidity sensors, measuring the ambient within the bus. You can have heater circuit monitoring to make sure that your heater systems are in functioning condition. Partial discharge monitoring is also becoming popular. And then newer technology like electromagnetic signature analysis or Emsa testing. So temperature and humidity sensors can be installed. Generally, these are ambient condition monitors that can tell if you have moisture within the bus duct. They can be set up to record and trend data, or can initiate an alarm. There's also the method of using an IR window with an IR gun. These can be placed in easily accessible areas, and they're quick and safe to access. But a lot of times with bus duct, especially isophase, where you've got transformer terminations near high voltage bushings, it's not accessible while that unit's energized. In those circumstances, you can use infrared cameras to remotely monitor those terminations. But there are also wireless and fiber optic sensors available for temperature monitoring as well. So this is just an example of infrared windows and IR window placement. Generally, those are going to be located at critical terminations, equipment terminations, and high ampacity terminations like your transformer terminations and generator termination boxes. So again, a lot of times these are not easily accessible when the unit's online. Heater system monitoring is a good technology for ensuring that your heaters are in proper working order. There's a couple styles to this design. One can be a general heater system monitoring box. This will let you know if some of your heaters are failing or if the system overall has gone down, and has indicating lights and can be set up to alarms. You can also have individual heater indicators with lights. These indicating lights can be seen from the ground. So you're able to walk along your bus duct and tell if those indicators are on or off, where a heater has failed and needs to be replaced at your next maintenance cycle. And then partial discharge monitoring, it's becoming more prevalent in the industry. There's also a lot of technologies available. Power coupling capacitors, they're great, highly accurate measurement devices. So these provide good data. They're online monitoring. So those are a good option and can provide detailed information. But there's a lot of handheld devices available as well. Audible devices and UHF measurement devices. There's a ton of these on the market, and unless you've used it just a lot and found multiple failure points, it's probably not going to be user friendly in understanding what the data means. So if you're going to use that type of device, it's important to use an expert that's got experience in using it. You know, a lot of these are more or as much art as it is science. So it's important to understand if you're going to use that technology, interpreting data is just as important as getting the device. And then Emsa Technology, or electromagnetic signature analysis. It's an online, non-invasive test. It can detect partial discharge, loose windings and loose connections, and a number of other defects. It's a non-invasive test, so you aren't introducing any high voltage or signals into the bus. And it can be used one time to determine data. It doesn't always require a trending test. So the Emsa testing process is pretty straightforward. It uses a clamp-on CT onto equipment grounds. It measures radio noise produced by defects and abnormal conditions. And again, it's a non-invasive test. It's performed online, so it can be performed prior to an outage to allow you to assess the condition of your equipment and determine if or when maintenance needs to be performed. So along with the one-time online test, there is a Watchkeeper technology available. So this uses the same testing technology as the EMSA testing, but it's 24 hours a day online and can be used to trend data and alarm if there are issues. So we want to enter into a couple case studies. We've covered the critical components of the bus duct. We've covered how those can affect your outage planning. So I want to go through a couple case studies here and show some real world examples of issues that have occurred in bus duct and how they can affect your system. So the first case study we'll look at, this was a phase to ground fault and a fire stop barrier. So a phase to ground fault in B phase began in the fire stop material. Failure of the protective relays led to eventual failure of the neutral grounding transformer. So once the transformer was lost, the ground fault propagated into an arcing fault within the bus. So the arcing damage caused significant damage inside the bus duct, but it also led to additional failures in the starter cabinet, ultimately resulting in significant cost to repair and downtime. So on the left, this is an image of a fire stop on an adjacent phase before it failed. On the right, you can see the fire stop barrier that did fail. It's got significant tracking and internal damage to it. So smoke and carbon particles spread throughout the bus duct, accumulated on insulators. And as part of that arcing fault, the neutral grounding transformer failed in the starter cabinet. It filled that cabinet up with smoke, led to an arcing fault at the starter switch, and caused significant damage to control wiring, to medium voltage cables, and the adjacent equipment. Ultimately, it led to complete replacement of the entire starter cabinet. So as part of the repair and the investigation, it was found that the previous fire stops had failed. So this was a known issue on this plant with this design of fire stop. So we began investigation on the other phases and other units. We did find some phases with very low test results on Megger testing, and that had really high leakage current or weren't able to pass high pot test. So we decided that was, it was worthwhile to investigate further. So we cut open the bus duct, investigated the fire stop and the material, and found evidence here of more partial discharge activity in this is actually C phase of the same unit. So this is likely what B phase looked like before it turned into a full arcing fault. So we went ahead with repair and placement of the unit. We replaced all three phases, the fire stop material on site. So we used a new fire stop or fire retardant foam that was used in another manufacturer's design, and replaced the insulation on the conductor and returned this unit to service. Well, before it was repaired, the outage was about 8 weeks long. They had to replace the starter cabinet as part of it, along with cryogenic cleaning and repair of the bus duct. So it was significant downtime and hundreds of thousands of dollars to complete the repairs. And another case study here, this is a bus duct that was not maintained for extended periods of time. So it had prolonged issues with moisture and lack of repair and maintenance. So moisture became trapped in the bus duct due to improperly installed bellows and failing gaskets. The buildup of moisture and condensation within the bus duct led to failure of the heaters. So this compounded the issues with moisture, led to significant corona activity and tracking within the bus duct and ozone buildup. They caused deterioration of the insulation. Eventually, this unit it couldn't stay in service. It had regular ground faults, tripping the unit offline, so it had to be repaired. So there's just some pictures from internals of the bus. So again, the moisture became trapped and it became stagnant within the bus duct. Deteriorated the paint on the enclosure and the conductor. You can see the silver plating on the terminations is pretty well corroded, along with the flexible connections there as well were corroded. So the condensation pulled in those heater boxes we looked at earlier, so it caused those to corrode and fail. So there were no longer heaters protecting the insulators from humidity. So the high humidity caused corona, partial discharge activity on the insulators, and significantly deteriorated the material. So it was a common problem throughout the bus. It wasn't a local issue. So you can see here the fire stop barriers, along with the new versus the old insulator, and the condition of a number of the insulators removed from the bus. So this was an extended period of time that all these were exposed to moisture, and that nothing was done to mitigate the issue or repair it. So eventually, this unit the damage was so extensive that repair really was not cost effective. So the units needed to be replaced. So usually when I'm in person, I do a show of hands for these couple questions. One, have you ever had a bus failure that led to outage time? And the second question is, do you currently have bus duct included in your maintenance planning? And what I find is most times the same people in the room raise their hands. So the important point of that is that don't wait till you have a significant outage or a significant event within your bus duct to add that to your maintenance planning cycle. So bus duct maintenance is a pretty simple process. It's straightforward compared to other electrical equipment with common principles. The most important thing is to schedule it and plan for it and understand what your baseline is for the unit so that you can extend the life of that equipment.
All right, Brian, thanks a lot. Let's move into the Q&A portion of today's webinar. Just like everyone to know, you can put your questions into the chat, or you can raise your hand and unmute yourself and ask the question if you don't want to type it in. The first question, Brian, is can you explain the silver plating process that you talked about in your presentation?
Yeah, so there's a couple different processes that can be used, but a general overview of it is to remove the old silver plating that's failing, to try to repair any pitting that's on those terminations there, and then using the way we do it is an electrolytic process where you redeposit silver onto those terminations, but it can all be done on site in place, so you don't have to remove any bus duct or cut out those terminations. It can be done where the bus is.
Okay, we have a question from Sashim. Sashim, can you unmute yourself, please, and ask?
Hey Scott. So I guess what we found on our Isophase bus was our B phase towards the generator side it had a hotspot of about 20 degrees Celsius warmer than the other two phases. We basically did a full-on inspection. This is our first one we've done in 20 years. We checked all the insulators, all the welded connections, all the flex connectors. They were all good. What we did find was towards the transformer end, we were missing a gasket on the B phase. So we thought maybe that was causing some type of circulating current that we had. We replaced the gasket, closed everything up, fired up the machine again, and we're still finding the same hotspot. Not sure, like there's no ground connection that seems to be missing. We're just not sure what this type of issue could be. Is it common, I guess, that the middle phase could be warmer than the other two phases, given that it's in between the other two, or is this maybe just an abnormality that we're seeing, or is 20 degrees Celsius not something to be concerned about?
So it's on the enclosure?
Yep,
Is it on the bus duct enclosure, or is it at the equipment terminations? Like
it's at the
booster box?
on the bus duct enclosure itself, where it comes out of the generator itself.
Well, I mean, there could be a couple different causes. It sounds like you've investigated the grounding and the gasketing, because sometimes that's used for isolation there, and that can lead to circulating currents and eddy currents. But that might be something that we can investigate offline. There's 20 degrees Celsius isn't a huge concern, but
Yep.
I would definitely suggest to monitor it and make sure that it doesn't progress any worse.
Yeah, well, the one issue that keeps showing up too is that since 2019, like they did a generator kind of repair for us, GE did, and since then we've been noticing our PD levels going up and up and up. Our Iris is convinced that if these levels of PD were in the generator, there would be an issue with the generator and we'd have major problems. But they're convinced it's something along the isophase bus itself. But that's all we've seen is a trend going up in PD the whole time, and now we found this hotspot recently, so we're just not sure where we're supposed to go with this.
Sure. Well, generally, an overheating issue in the enclosure and the PD in the insulation, those are probably not coming from the same issue, but I wouldn't rule it out necessarily. So I think what we probably need to do is look at your specific situation and what's attached to your bus duct, the type of design and materials that it's used in the manufacturer, to be able to investigate a little bit deeper.
Sure, and we'll probably just reach out to you guys then. Thank you.
Okay, Brian, what determines voltage levels applied for high pot testing isophase bus bars?
So high pot testing voltage is going to be determined by the BIL rating of your bus, which you'd have to look at your rating nameplate or your drawings to determine what that is. But all manufacturers are going to specify that in their design data. So generally for isophase, it's going to be 110 kV BIL, 125 or 150, and you'll take that and look at IEEE and C3723 standard to determine what your field test voltage is. So there is a difference between factory test voltage and what you would test it in a maintenance condition. That's generally going to be 75% of what the factory testing is, your design testing data.
Okay, is it
I
okay
guess
to remove? What's
Yeah,
that?
sorry. I was going to say, I guess to answer directly, I'd have to know what the bus ratings that he was asking about is. But IEEE C37 will provide some direction on that.
Okay, is it okay to remove the fire barriers and continue working? Or continue operating?
Yeah, I mean, you can. It's gonna the reason the fire stop barriers are there is to prevent that smoke and debris from entering the rest of the bus duct if you do have a failure at your transformer. So it's not, there's nothing that's going to cause your bus to fail by removing that fire stop barrier, unless it's also acting as a seal off bushing. But you have to evaluate that with what type of design you have in your system. But in general, it's an added protection to eliminate, debris and contaminants from entering the rest of your bus.
Can you talk a little bit about the significance of DLRO pre and post outage with other links in place?
So for DLRO, so they mentioned the links. So I'm assuming that this is at the equipment termination. So a generator, or a transformer. That's my first guess. I'll cover that. So it's not. It does. Some customers do require that. I wouldn't say it's the most common practice because internally to those equipment, your transformer, your generator, you're going to have that bus tied together, so it creates parallel paths. So it won't be as cut and dry of a result as it would be if that bus was isolated. You were actually testing the conductor, but you may see some discrepancies from phase to phase that you could investigate. But usually inspection of the plated surfaces, the condition of the flexible braids, following what the OEM recommends for number of braids and placement, and then following proper hardware and torque standards should ensure a good connection there, along with greasing, some anti-corrosive grease as well. So that's one situation. Another would be for like a non-segregated phase bus duct. If you made some modifications somewhere, or if you had a disconnect where you can test all the way through one phase without parallel paths, I would definitely recommend that as part of your return to service practice and maintenance practices, to make sure that each phase is consistent and that there's no significant changes from the last test data that you have.
And Blake, if you have anything to add to that, feel free to unmute yourself and ask Brian. Okay, we'll go back to high pot testing. Can you talk about the differences and or the benefits of using a DC or an AC high pot test?
Yeah, so both are generally acceptable tests. IEEE specifies AC almost primarily now for both switchgear and bus duct, but that's really for the design testing. The issue with AC high potting, especially on an isophase bus run, if it's of any size or length, is the capacitance in the system. Sometimes, especially really high ampacity, like 20 or 30,000 amp bus ducts, you're going to need a significant AC high pot to provide enough power to test that bus. So it is common to find DC bus or DC high pot used in those circumstances. If it's possible with the equipment you have, or you can access the equipment, I'd recommend the AC high pot, especially for non-segregated phase bus. But in lieu of that, there is different test values for AC versus DC to compensate for that. It's very common to DC high pot isophase, and there's really no major concerns with that. It's gonna give you a good indication of what condition your bus is in either way.
Thanks. Do you have any experience in painting the interior of the bus after a significant amount of paint has been removed due to a nitric acid attack?
I would imagine that'd be very difficult. I don't have any personal experience with it, no. Really the reason that the interior is painted is for heat dissipation, to support with radiative heat transfer. So you may lose some cooling capacity, but if you're monitoring your bus and there's no hot spots, I don't know that I would try to go through that much effort to repaint the inside of it. More just monitor, the critical components we talked about today. Make sure you aren't experiencing any heating issues or major corrosion issues after you repair the significant damage there.
Okay, we've got two more questions. Is bus duct enclosure to be grounded from only one side, and when should it be grounded from both sides?
So usually bus duct manufacturers are going to specify a single point ground. But depending on the type of design in your system, there could be multiple single point grounds. So, for example, an older non-continuous design, they have multiple sections of bus that are tied together with, with a flexible connection or some type of insulated joint. So each one of those sections is going to have a single point ground. You could also have another example would be if you have a GCB in your system and you have rubber bellows attached to both sides of the GCB, that would be a non-conductive joint there. So you probably have a separate ground on both shorting plates in that area. But generally on one section of bus with shorting plates on all ends, you're only going to need one ground on that section of bus.
Okay, and the final question is, how do you indicate that there is an eddy current circulation problem?
So one way to investigate that is using an IR camera. So that can tell you if you've got elevated temperatures at grounded connections, or if you're seeing circulating currents in your enclosures or shorting plates, or equipment that's supposed to be isolated, like a transformer bushing box. If it does have some contact, you can see some local heating using an IR camera. But as far as investigating what the source is or what's causing it, that can be a pretty in-depth process. It just depends on the type of design of the bus, what kind of support steel you have around it, and verifying that you have proper isolation of your bus duct if it has isolated connections from your support steel.
Okay, Tamir, if you'd like to unmute yourself and talk a little bit more in depth about your system, you're welcome to. But other than that, we don't have any more questions. And if you scroll through your chat, folks, Brian's contact information, phone number, email, and the RMS Energy website is all there for you. We'd like to thank Brian and RMS for today's great presentation, and the recording and the presentation slides will be available to attendees and registrants. So we should be sending that out to you in the next week here. Thanks a lot for joining us. Wait, we do have one more question, Brian, before we go. We have several non-seg bus duct failures due to moisture intrusion and non-functioning heaters. The system is installed in the switch yard. What type of maintenance should be considered for these types of systems?
For non-seg, especially outdoor, maintaining your heaters and ensuring that they're in proper working condition is critical. So you can replace those. You can also add that heater monitoring circuits to it. But if it's had prolonged exposure to moisture, you may need to replace insulators and internal components there. If it's because of the condition of the roof or you're missing ridge caps, those should be repaired. You can also add a rain cover in some cases if the top's really in poor condition. So there's a number of potential solutions there. I think it depends on what type of failures you're having in the bus duct and how severe they are and how long it's been in that condition. So if it's just a newer problem and there's a lot of moisture, you can replace gaskets, try to seal it up, maybe add a rain cover to prevent moisture from accumulating on the top. But if you're pretty far into partial discharge activity and surface tracking on insulators and barriers, you may have to look at refurbishing the bus, re-insulating the bus, and replacing those barriers, or if it's a persistent problem, eventual replacement of it.
All right. Well, thanks very much, Brian. And thanks to everyone for joining us. We hope you got your latest issue of Combined Cycle Journal in the mail recently. If not, you could always go online and subscribe. Thanks a lot for joining us, and we'll see you next time.